Good day, class. Today we're going to go over a quadratic and polynomial functions test review. And what we're going to do is we're going to go ahead and go over a few problems. Well, actually, we'll go over through the review. Now, if you're watching this video, remember, please try the work before I do it. And then either you could look at the rest of the video to see if I did it, or see if you did it right. And then you could go ahead and see if you didn't know what to do, what you need to learn from it. So the best thing to do is to pause the video, try it if you haven't done so already, and then continue forward. Start playing the video and see what I'm doing. Now, probably a good thing to do is go back and try it again. That means even after you saw that I did, see if you can recreate it. And the reason being is because sometimes you need to sit down and say, hey, do I really know this? Because sometimes you see it and you're like, oh yeah, I know this. But then if you got a new blank sheet of paper, you may want to just go back and recreate it again, just to double check you understand and could apply these formulas. Because like on this first one, we're looking at a quadratic, and we have to determine first, does it open up or down? We have to find the vertex, axis symmetry, the y-intercept, the x-intercept, and it wants us to use all formulas. So that means we're going to use algebra techniques to find this out. Now, as far as if it opens up or down, remember, this is A, B, and C. If your A is less than 0, then it's going to open down. That means that if it's greater than 0, it would have opened up. In this case, we open down because my A value, my very first value in that quadratic, is less than 0. Now, to find the vertex, there is a formula. Let me write it down in case you forgot it. Negative b over 2a, and the f of negative b over 2a. Now, lucky for us, this negative b over 2a, that means I'm going to take this value 6 and do negative 6 and do 2 times negative 3, which means I have negative 6 over negative 6, which means my value is 1. Now, you know how I was asking for the axis of symmetry? This value is also the axis of symmetry, so you could write already the axis of symmetry is equal to 1. So that means that the axis of symmetry is 1, and the other thing is that my vertex, I have my first x value, because they're both the same. Axis of symmetry and the x value for the vertex are going to be both the same. And the only thing I have to do is find this other piece right here. What is f of 1? So for that, let's go back to the equation. Let's go ahead and type 1 here. If 1 goes in there, 1 goes in there, 1 goes in there, we will have then, and let me go ahead and erase some of these items. So we go ahead and actually get we already have that it opens now. Oh, well, we should have written down that formula already for the vertex. So let's go ahead and write this down, and so I have negative 3 over 1 squared plus 6 times 1 plus 1. This is just negative 3 because this is 1 times that plus 6 plus 1. So in my case, I'm going to get, let's see, 3 plus 1, which means I have 4. Which means in this case, where it said f of 1, I can go ahead and fill that with 4 now. So I have the answer 4 there. Fantastic. All right. Now let's go ahead and do the other parts of this, and I'm going to leave that there. Well, actually, I probably want to graph it already. 1, 4. There you go. All right, so I have my axis of symmetry. I have my vertex. Actually, I can probably go ahead and fill in my axis of symmetry already. Now, the only thing I have to do now is find my y-intercept, y and x-intercepts. So let's go ahead and do that. Now, I'm going to erase this part here. So I can go ahead and find my x and y intercepts. I want to do this, erase all this right here. And this over here too. Because I want to make sure that we have enough space for everything. Now, as far as finding the x and y intercepts, now y-intercept is pretty easy to find. That's going to be when x's are 0, basically when this is 0, this is 0. That means that these cancel. Which means that when x is 0, like I put in there, my y-intercept is going to be at 1. So here's my vertex. This is my y-intercept. Okay, and here's my axis of symmetry. I'm doing that just because it asked me to label all the information on the graph. So I just went ahead and did the first couple of parts. Now, as far as finding the x-intercept, let's go ahead and do that. Now, as far as finding the x-intercept, let's go ahead. Oh, one other thing. If you have a 1 here, there's also going to be a point over here just because with the quadratic, it's symmetrical. So this is just because of the because I need to come up with 5 points. So I have 3 points so far. And you could say this is symmetrical. The symmetry property of a quadratic. It's symmetric. The only thing I have to do is now find my x-intercepts, and for that, we're going to go ahead and use the quadratic formula. -b plus or minus 2a b squared minus 4ac. The only other method you could think about, well, there's a couple other methods, but in our case, algebraically, is if you could factor that. But in our case, I'm not going to do that. I'm going to just use the quadratic form. Just because some of these are not so easy to go ahead and just factor. So, -2a. Now with that, let's go ahead and apply it. First of all, -6, remember we take the opposite of b, plus or minus -6 squared. Remember, if you're going to put that in the calculator, you got to put in parentheses, -4, -3 times 1, all over 2a. Oops, actually I'm writing down the equation. Let's go ahead and erase this, and we're going to go ahead and put down the actual thing, which is -3. Alright, fantastic. Let's go ahead and move on with solving this. This is -6 plus or minus. This becomes 36, and this becomes +12. And this is over 6, -6. So, which means that this becomes then -6 over -6. All I'm doing is separating this, plus or minus square root of 48. And from here, I'll get 1 plus or minus, oops, forgot to put my -6 here, -6 there, square root of 48 over -6. Now, this is where it becomes handy. Let me turn on my calculator on this one, because I want us to figure out what -6 over 48 is going to be. And if you wanted to simplify radically, you could as well, because you're able to do that, but since I want a numerical value, I might as well just go ahead and do the quadratic formula here. That's what we're doing now. Okay, great. Alright, so square root of 48 is 6.9 divided by -6. Is going to be -1.15, which means, I have to move this because I wanted to move it over here. There you go. Okay. The reason being is that this now equals, oops, ooh, move that. Okay, do that. The reason being, oh, you know what, there's actually a little chart here that we can fill out. Let's go ahead and start filling that out as far as this chart. Well, let's finish this. Then we'll get to that chart over here. Alright, so now let's go ahead and write down, this is 1 plus or minus -1 point, let's see what that number was exactly, 1.15. So 1.1547. Okay, so from here, we're going to go ahead and write down our two x-intercepts, which is plus or minus this amount. So, go back to, well, yeah, there you go. We do that first, because I want to make sure that I'm able to type on this. So 1 plus -1.1547 comes out being negative. So one of my x-intercepts is going to be negative. Do that and bring that back up. -0.15, so really close to 0. And the other one's going to be, it's going to be the 1 minus that amount. Because remember, you see the plus or minus, that means you're adding and subtracting. 547, which comes out being the 2.154. Oh, negative. So that means there's my two intercepts in this case. So we could go ahead and plot those down and finish up my graph. I mean, one of them is going to be right here. Negative, yes. Well, actually, no, it was positive. I'm sorry. I don't know why I thought it was negative. Why I wrote down negative. It's going to put that as a positive. And the other one's going to be 2.154, which is going to be right over here. So in this case, I'll have a parabola that opens down this way and this way. Okay. Now, so when filling this out, so you could put down x-intercept. Remember, we're labeling all pertinent points, so we need to do these things. And the other thing now that we're going to go ahead and write down, this opens down. The vertex was 1, 4. Axis symmetry was 1. The y-intercept was 0, 1. And these you could put x-intercepts as, just to make it official with the zeros at the end. I can actually put them down as points. Now the domain on this is going to be all real numbers, just because. Let me go ahead and take you back up to the graph. You see the graph, see how the arrows go out this way. So basically it's going to go this way and this way. So this is going to continue as far as the x is going to hit negative and positive infinity. Now as far as the range stops here. If you notice, this is where the range stops. There is nothing over here. So that means that in my range values is going to be, in this case, everything less than 4. So y is less than or equal to 4. Now, when is it increasing the interval? Well, the interval for increasing, again, so we hear from negative infinity, because remember, I'm increasing from somewhere over here all the way until I get to this point. This is all my increasing line, or you can think about this as increasing here. So that means that in my case, I'm going to be increasing from negative infinity to 1, and actually should be included on this side because it's right at 1 where it stops. So if we 1, let me go ahead and correct something small that I did here, because this should be then closing bracket, and it's decreasing from here to here. This is where it's decreasing. It's decreasing everything on this line, so we're decreasing from 1 to positive infinity. And there you go. And remember, important about the bracket and parentheses. Alright, let's see if there's anything else I forgot to... No, I labeled all my pertinent information, vertex, everything else. I also labeled the minimum and the 5 points in the graph. So, we are all set with this problem. Okay, now that was the only problem on this page, so let's go ahead and move on to the next one. And now, let's see if we can solve this, or start solving this one. It says graph using transformations in Scholar work. It says, first of all, you need to rewrite the form into this form. Now remember, we call this vertex form. And we said mathematicians love this form because it's easy to see the vertex and the transformations. So it says you need to first rewrite that by completing the square. So let's go ahead and start with that task first. Okay, now in rewriting, remember when you complete the square, the first thing you got to do is factor out an a, which means I'm going to factor out that 2. Now, in factoring out that 2, this is negative 8 is composed of 2 times negative 4. So this is going to be a new b I'm going to be left with. So I'll have x squared minus 4x. And then I'm going to leave some space here and put a plus 9 because eventually when I'm completing the square I need to put down a magic number that goes there. And the magic number will also be the number that's going to be used down over here as far as the value that goes in here. So because eventually I'm going to end up with this and something adding over here. So I'm going to have something new here and here. Now the magic number is found by taking your new b, which is this b here, and doing negative 4 divided by 2 and squaring it. So in this case, that's going to be negative 2 squared, which is going to be 4. So this is going to be plus 4. And in my case, I'm going to go ahead and put this as that magic number that's here. The magic number was In this case, it was -2. So this was -2 that goes there. So now one thing that's important that we have to keep in mind that when we're doing this, okay, this number that I had appear here, this number, to keep the equation balanced, I got to make sure that I do this over here, or this basically this 4 that showed up here. I got to make sure that I keep that balance, and I'm going to do that by taking this 2, multiplying with that, and subtracting it on the other end, because in essence, if I distribute this, I would get an 8 here. So I'm going to do a -8 over here to get the new number here. Now, after that, I'll get +1. Okay. So with that, I'm able to complete the square. And if you're ever in doubt, if you completed the square right, you can always just check this. Go ahead and see if it gives you back the same binomial. And I'll do it for you. If I pull it real quick, x squared minus 2x minus 2x plus 4, x squared minus 4x plus 4. Okay, now the negative, I knew that the negative came from that value there, as far as this -2 right here. It comes from the 2 places, either the negative there and also from the actual b value. So this one, that's how you know that was part of the negative there. So now you complete the square. Now, after you complete the square, let's go ahead and start, now it says graph the function starting with the graph x squared. So you're going to graph the x squared graph here. And that's a parent function. That one's pretty easy to graph. All you have to do is this. And remember, try to use 5 points if indicated. Make sure you use the 5 points. And then it says right here, graph the function starting with f, and then using the transformations. So now after that, let's go ahead and graph the rest. So like in this case, this one's going to be a new vertex on this. It's going to be 2, 1. That's one thing that occurs with that. Axis symmetry is 2. And that came from here. And then also let's see, the last place is, well, actually like the equation in vertex form. It wants us to write it here. So x minus 2 squared plus 1. Explanation and transformations. First of all, the vertex is going to be shifted. Vertex will be shifted to the right. 2 and up 1. That's one thing we're going to first have. And then after that, we're also going to have the, well actually that'll be part of the transformations. And then the other thing we have is that a value of 2, a equals 2, well actually no, this value here is going to be, means that we're going to go ahead and stretch vertically. Okay, and stretch vertically because that's what that a value does. Now, let's go ahead and graph this. So first of all, 2, 1 will be our new vertex, and it's going to be stretched vertically, so which means that instead of this being here, instead of originally this point being here, it's really here now. That's what happens with that 2 value. It stretches everything vertically. And this, or you could think about it as, so I guess the best way to put that is stretching. And then after that, if I would have originally had 4, it's going to be higher up. So basically, see if we're able to even do this. Instead of 2, 4, you're going to have, or this, you're going to have basically from here 8 values up. So you're going to be way up there. So basically, I'm just going to go ahead and, oh well, I'll go ahead and do just graph it. That would be the best way to do that in this case. Because it's not really, oh no, they do want 5 points. Because it says you want us to label the 5 points, axis symmetry, give all pertinent information graph, including the vertex, axis symmetry, and everything else too. So in our case, let's go ahead and get the other values. We have to get the, like with this one, it's going to cross at 0, 9. So let's put that there. And actually, that's probably what the other point's at. Because yeah, it would be 0, 9. we have a point here. So you know what I'm going to do is I'm going to take away my graph. So I'm going to undo this. So that graph is gone. There we go. Because this is 8, and this is 9. So this being 8 and 9, there's my other point. And that means I'll have another point here. Now, this one, first of all, and this means my y-intercept. This is my vertex. This is my axis of symmetry. Here's my other point of symmetry. And these other points, I got them just by plugging into the equation. And what I mean is that if you plug this 3 value in here, into this whole equation, this 3 value there, it will result that as a point. And the same thing with this one. If you plug in 1, that same thing. So by plugging those in, that's how you originate these points. So they're just points on the graph. That's really all you want to do. If you want to label them, you can label them that way. And then this one had no x-intercepts. And if you ever want to, you can always use a formula to verify that as well. Just taking the b squared minus 4ac to see what it gives you. And let's go ahead, and I think that completed most of anything here. There's explanation, transformations, we did that. That's all been done. Okay, great. Now let's go ahead and question 3. Since this one, form a polynomial whose zeros and degree are given. So, if you're given the zeros, those are basically like the x or y, well, I'm sorry, those are the x-intercepts. So in this case, my function on this, to produce this, I have to have then x plus 2. Because that means that the x value, -2, will result that as a 0. That's how you know how to generate it. You basically take the opposite of it. Now, it wants a multiplicity of 3. This is important because that means that multiplicity means a degree of 3. Now, it wants just a 0, so that's going to be multiplied just by x. This one's generated. I'm going to put it in the front here because that's normally how you're used to seeing it. Or I've seen it in other examples. You want a value of 3, so we'll have x minus 3, a 0 over x minus 3 to produce that. That's the value that if we went in there, it would make that 0. The multiplicity of 4. Now, the degree 8 just needs to be it's going to be verified because you see how you have 1 here? The degree is by adding up all the powers. So the degree in this case, 1 plus 3 plus 4, which results in a degree of 8. So we have a correct polynomial who's given these zeros with these type of multiplicities that we're looking for. Okay, great. Let's go ahead and go over to the next one on this. And it says right here, determine the quadratic whose function in the graph is given. And it says begin with the vertex form. Well, with this, one of the things you need to realize is that we're able to find the vertex form. Well, actually, you're able to find the standard form, but the vertex form you're able to get because, first of all, we're given the vertex, which in this case it's 2, -3. So that means that if I have my vertex form of the equation, which in this case a x minus h squared plus k, go ahead and fill in a couple of things already. Right off, I could go ahead and I probably could determine actually quite a few things just by that. Because you have another point over here, which is, this point is 0, 5. You go ahead and actually determine the A. Now I'm going to do it all by hand because I want this, because remember, I got a point. This is x, f of x. So I'm going to fill that in. I'm also going to fill in my h and my k. So like in this case, I'm going to go ahead and fill in. First I'll start with x, f of x, so you'll see that, 0. And actually, no, I put the 0 in the wrong spot. I'm sorry about that. Let me go ahead and correct that. This is going to be equal 5. So you're going to have 5 because that's the f of x. You see how f of x is equal to 5 right there? And the other one's going to be 0. What am I missing? everything else. Now, A is what we're going to try to solve for in this case. So we have 2, and we have k, which is negative 3. Okay, fantastic. Let's go ahead and start solving this. This one is pretty easy to solve. Now 0 minus 2 is going to just be negative 2. Plus negative 3. I'm going to go ahead and solve for that, so I'm going to, it's really minus, so I'm going to add positive 3. Add positive 3. Cancels out, that gives me 8 equal to negative 2a. I went ahead and reverted this so it could look more familiar to you. Negative 2 means that a is really negative 4 in our case. And let's see if I did all that correct. Positive 3. Yeah, so then in this case, a is going to be negative 4. Alright, now a couple of things we have to do, just because I noticed that I did make a mistake on this, and the mistake came in here. And actually I'll erase it, and I'll erase all this right here, so go ahead and erase it on your side. We didn't, one of the things I didn't do, if you notice on your notes, I didn't square that part. That needs to be squared, and that plays an important role because it changes your answer completely. And the way I noticed is that when I saw that my a came out being negative, that indicates my parabola should open down and my parabola opens up. So anytime you notice when something doesn't make sense, that means a mistake has occurred. So like in this case, you would have gotten squared plus negative 3, and you would have ended up with a then 4 plus negative 3. Now from here we go ahead and add a positive 3, add a positive 3. That still cancels, so we still would end up with this 8, but instead of 2a, the negative 2a is ahead before, now we're going to have 4a. So you just divide by 4, you find out that your a is 2. So with that, actually now that I know what my a is, I'm going to go ahead and now put it back onto the equation. So let me go ahead and erase all that up here. And I should be able now to get this in standard form, because now I got pretty much all kinds of components. It's everything I need to get this in standard form. A is 2. This is x minus my vertex, which was 2, plus negative 3. So all I need to do here is FOIL. So let me go ahead and do that. Go ahead and FOIL the x minus 2 and the x minus 2. So I end up getting x squared minus 2x plus 4. And let me erase this part here. And I'll end up getting then, remember this is a parentheses with the 2 still on the outside, and this plus negative 3 still here. So now these combine in the middle. This comes out being negative 4x. And all I have to do here is distribute. So the distribution of that will make 2x squared minus 8x plus 8 plus negative 3. So the vertex form of this one, actually you just want to put equals. It's going to be 2x squared minus 8x plus 5. And there you go. This is your standard form of the equation by just being given a graph. That's how you want to do this when you create this problem. Okay, fantastic. Let's go ahead and move on. And there's where the solution goes. So if you want to be formal, you could just go ahead and write that in there. Actually, on the test, you want to make sure you do write it in there, because you want to have that. Okay, so now with this one, question 5, it says list each 0 and its multiplicity. Well, we have a zeros here, we have a 0 here at 1, negative 3, and negative 4. So you have 0, 1. This one is the multiplicity of 1. And the multiplicity because of that. This one is negative 3 is another 0. Multiplicity of 2. And the last one, negative 4, with the multiplicity of 2 also. Determine if the graph crosses or turns in the x-axis for each x-intercept. While for 1, it's going to cross. So for the 1, it will cross. And the reason being is because when you got a multiplicity of an odd number, it's going to cross the x-axis. For -3 and -4, it's going to go ahead and turn at the x-axis. And the reason being is that if you ever have a multiplicity that's even, it's going to turn, and it's going to become a tangent there. Okay, identify the power function that resembles f of x. The power function is just taking the degree. So you take the degree of this function, it's going to be then 1 plus 2 plus 2, which equals 5. So my power function then is just x to the 5th. That's what's going to resemble in my case. And it's just found out by taking the degree and applying it. Okay, great. Let's go ahead and move on with the rest of this review. Okay, now this one has to do with the review as a function of x. Now you got to remember one of the things you have to memorize is revenue, not the review, revenue. Revenue is expressed in terms of x and p. And when you want it as a function of x, that means you cannot have this expressed as a p, products, or price. It needs to be expressed everything as quantity. So like with this first one here, we have to go ahead and solve for, actually this one's already been solved for you. So this one is actually kind of easy since it's already been set up for you. All you got to do is substitute. You got x, -1/2 x plus 80. And this is going to distribute the x. That means that my equation really then is -1/2 x squared plus 80x. And that's my equation. So my revenue equation, as expressed as a function of x, is going to be -1/2 x squared plus 80x. Sometimes this equation right here is given to you in terms of x, so sometimes you got to solve for p, so you can substitute it in here and do what we just did now. But this was easy because we had it in here. Now this one asks us what is the revenue of 100 units are sold. Let's go ahead and apply that. -1/2 100. Use our equation. So we look at the revenue equation as a function of x squared plus 80 times 100. So let's see what that comes out being. I'm going to pull out my calculator. Ooh, came up and came back down. Here you go. So let me clear this, and I'm going to go ahead and put -1/2. I like to use, remember, always use parentheses wherever you can, where applicable. -1/2 times 100 squared plus 80 times 100. So there you go. And it gives you 3,000. So my revenue on this one, the answer would be, oh, it's writing. Let me put that exactly where it should be. It should be 3,000. So there's my answer for B. And then this one's talking about what quantity x maximizes the revenue. Remember, this is a parabola. And you remember how you see the A? You see how the A is negative in this one? That means in this one, you're going to have upside down parabola, and there would be a certain point, which is a vertex, that will tell you first the x. So when you find the vertex, it's going to tell you where you have the x, and also will give you the maximum revenue for that x. That's really what that vertex is going to say for us. So we got to do -b over 2a, and also find the result of -b over 2a, and that's going to be these two right here. The quantity is going to tell us the quantity because that's what x represents, the quantity, and the function of that quantity will give us the revenue. So I'll erase these once we come up with the answers. So like in this case, -b is -80 all over 2 times -1/2. Good. So now let's use our calculator to figure out what that is. So we got -80 divided by parentheses 2 parentheses -1 divided by 2 and parentheses enter. Okay, so it's going to be 80. It's exactly 80 units. So our quantity in this case, I'm changing here, it's going to be 80. So let's go and put this as 80 there. Okay, great. Now let's go ahead and see what the function of that is. So instead of putting 100 in there, we're going to go ahead and put down 80. So let's go back to this, and I'll type in our actual negative 1 divided by 2. I'm going to find the f value of what is 80 squared. Well, actually, it was plus 80 times 80. See what that produces. And that produces 3,200. Now you notice how it's bigger than actual other amount that had a bigger x of 100? That's because that is where the maximum revenue is met, at that production amount. At that production amount, you got 3,200. Okay, great. Let's move forward. So what price should the company charge to maximize its revenue? This is where you take our original equation, and you take the original P, and we're going to go ahead and actually just take this equation and reapply that 80 that we knew. So in order to figure out what price should be charged, we're going to do 1/2 times 80 plus 80. So let's find out. And let me go ahead and get my calculator back out. Let me clear this. Negative 1 divided by 2. And we're going to do 80 plus 80. Means that $40 should be the revenue, should be charged there. And all I did is reapply it to my original price equation, wherever that happened. So it was exactly at $40 that occurs. At $40. Okay. Let's see if there's anything else that we're doing for this review. And no, I think that's it. So we went ahead and covered a couple of things. I would say that go ahead, if you didn't try these problems, if you saw this video, probably a good idea for you to go ahead and do is retry them. You know, write them out on a 7-piece paper, try them again, see if you can replicate them. And if you can, then that means you mastered what we're doing. Especially if you could show somebody else. That's really one of the big tests to see that you really know how to do this. Okay, great. Good luck on tomorrow's test.